Select the Enable All option from the Borehole Manager Edit pull-down menu. This will ensure that all of the stratigraphic content from all of the boreholes is included within the subsequent modeling. Select the Layered Model option from the Borehole Operations Stratigraphy pull-down menu. Enable the Interpolate Surfaces option. Otherwise, the program will assume that the grid models representing the tops and bottoms of all the stratigraphic units have already been interpolated. We'll be discussing these gridding methods or algorithms later on. In the meantime, if you have a burning desire to know more, click on the big red question mark in the upper right corner of the Layered Stratigraphy Model menu, or click on the small video icon for the currently selected algorithm. For now, let's just use the inverse distance algorithm. Turn off all of the additional embellishments except for the perimeter cage. Disable all of the additional interpolation operations, such as the volumetrics. Click the Gridding Method Options tab and disable all of the options. Click the Continue button. The program will now interpolate grid models for the top and base of each stratigraphic unit to form a stratigraphic model that is displayed within a new RockPlot 3D tab. The diagram may be enlarged or reduced by adjusting the Size button within the Options ribbon. Notice the small plus button to the left of the strat model within the data tree. If you click on the plus button, the individual units will be shown. Checking and unchecking the boxes adjacent to each unit will render them visible and invisible. Let's click on the Options button and we'll make some improvements to this diagram. We'll start by changing the gridding method to the radial basis function, or RBF. Next, enable the Diagram Hide Thin Zones option and set the thickness cutoff to 1 meter. This will render the thin zones as invisible, thereby showing areas where the units may have been eroded away or never deposited. Check the Strip Logs box. Select the 3D Log Design tab. Turn off everything except for the title, axis, and stratigraphy. Click on the Continue button. Notice that the stratigraphic logs are visible and that the thin portions, or less than 1 meter thick, of the units are not visible. Finally, let's append the contents of another RockPlot 3D file to show how that's accomplished. Select the Append option from the File pull-down menu. Double-click on the benzenelogs.rw3d file. The benzenelogs.rw3d file was created in Exercise 2.6. If you don't have this file, pick some other R3D file and pretend that it shows 3D geochemical logs. Turn off layers until you can see the benzene logs, or double-click on the strat model and set the transparency level to 50%.
RockWorks gives users options for creating 2 types of stratigraphy sections. Straight line sections, where the program simply draws straight line contacts from hole to hole, and modeled sections, where the program actually slices through the grid files for each formation model to create the section. In this step, we'll create a model-based diagram. Choose the Stratigraphy Section Model-Based menu option. In the Main Options tab, the settings on the left side of the menu should look like this. Click on the 2D Log Design tab located along the top of the menu. Enable the title, depths, and lithology, and disable everything else. Click on the Section Location tab at the top of the window. A familiar screen showing your last section line should appear. Click on the Clear button to erase the previous selection and start a new section line. Do not select any of the boreholes with lines because those wells are not vertical. Non-vertical boreholes can only be plotted with the Profile and 3D programs. If you do happen to select a non-vertical borehole, the program will treat it as vertical and you'll end up with a bad cross-section. We'll be showing how to use the profile in 3D programs for dealing with non-vertical boreholes later on in the training.
When you create a modeled fence diagram in RockWorks, the program takes a stratigraphy model like the one you created in Exercise 3.1 and cuts slices through the model based on the user's specifications. Choose the Stratigraphy Fence Model-Based menu option. Enable the panel borders and legend options and disable everything else. Set the legend type to Stratigraphy and click the Fence Location tab. Make sure that the Snap option is disabled. Fence diagrams are made up of vertical panels, so click on a panel starting point and then click on a panel endpoint. Repeat this process until you have defined all of the desired panels. Click the Continue button. A new Untitled tab page will appear with the fence diagram. Enable and disable the legend. Try turning the individual panels on and off. Click on the Spin button and then hold the mouse down and move it right, left, forward, and backward to tilt and rotate the scene. Click the Zoom button. Click on a corner of an area to be enlarged and then drag the mouse to the opposite corner. Click the Unzoom button to zoom out to the default scale. Click the Move button and drag the diagram around the work area. Increase and decrease the vertical exaggeration setting. Change the background color. Experiment with the spin options. Adjust the size setting. Now, let's save this diagram by clicking on the File Save option within the RockPlot 3D tab. Enter Stratigraphy Fence for the file name. RockWorks will automatically add the RW3D file extension if it's missing. Let's append another RockPlot 3D file onto this one by selecting the File Append option from the RockPlot 3D tab. Select the lithologylogs.rw3d file that we created in a previous exercise. The first thing that you'll probably notice is that the stratigraphy legend is overplotting the lithology legend. To fix this, double-click on the stratigraphy item within the Legends group. Select the right side option from the Location and Size group. Click the Close button. The stratigraphy legend is now plotted on the right side of the diagram. Finally, we encourage you to experiment with enabling and disabling items within the data group.
The Stratigraphy menu also has tools for viewing structural contour maps and Isopach maps of stratigraphic units. Start by selecting the Stratigraphy Structure Grid program. Click on the down arrow at the right edge of the stratigraphic unit box. Select the Spurgeon formation from the list of formations. Verify that the surface or top option is selected. Click on the Output Grid tab and set the grid name to spurgeonstructure.rwgrd. When you are naming this new grid, you may notice that the program has already created grids defining the top and base of each unit for the stratigraphic model in Step 3.1. This new RW grid file will not affect the grids in the model as long as you choose a different RW grid file name. Click on the Gridding Method item and review the settings. These settings can be left as they were when we created the stratigraphic model in Exercise 3.1. These algorithms and their nuances will be discussed in more detail within Exercise 12. Enable the 2D Grid Model option and review the map parameters. Enable the colored intervals, contour lines, labeled axes, map overlays, borehole locations, symbols, borehole IDs, and peripherals. Disable everything else. Click on the Peripherals option and enable the north arrow, scale bar, and colors. Make sure that the 3D grid diagram option is disabled and click the Continue button. A new RockPlot 2D tab will be created that shows a contour map depicting the structural elevations at the top of the Spurgeon Formation. Click on the Color Legend item with your mouse and move it to the right. You can also resize it by clicking, holding, and dragging a corner handle. If you double-click on the legend, more options are available. Experiment with removing and inserting check marks in the different layer names to see their effect upon the display. Close this window. You do not need to save the RW2D file.
Select the 2D Isopach map program from the Borehole Operations Stratigraphy menu. Set the superface or top of Isopach to the Potosi Formation. Select the Use Top of Stratigraphic Unit sub-option. Set the subface or base of Isopach to the Potosi Formation, and select the Use Base of Stratigraphic Unit sub-option. Before we move on, notice how you can use these options to create Isopachs for groups of stratigraphic units. Most of the other settings will be maintained, but let's change the labels that are displayed within the point map. Click on the 2D Grid Map tab. Be sure that the Map Overlays layer is activated. Also, make sure that the Borehole Locations box is checked. Enable the Stratigraphy Data option and set the stratigraphic unit to the Potosi Formation. Turn on the Thickness option and click the Continue button. The resulting map should look similar to the one to the left. Next, we'll create a custom colored table so that the map can be displayed using a different color scheme. Before we do that, however, note that the thickness of the Potosi Formation ranges from 0 to 50 meters. This will become pertinent in a few minutes. Click on the Options tab. Select the Custom Scheme from the 2D Grid Map Colored Intervals tab. Click on the Edit button. A listing of all of the existing colored tables in the current database will be shown. For this map, we'll create a new one, so click on the New Table option. Enter Potosi Isopach when prompted for the table name. A color-filled table is used to define a listing of value intervals in their corresponding colors. These tables are used by programs when building 2 or 3D color-filled contour maps, solid models, and strip logs. This window permits you to enter the order, minimum, maximum, and color manually, or use the palette button as shown within the next step to fill the table automatically. You may list as many value intervals and colors as you wish. Uneven and discontinuous intervals are supported. Click on the Palette button and select the Single Range sub-option. Enter 0 for the minimum, 50 for the maximum, and 5 for the increment. Click the OK button. The table will now be populated at 5-unit intervals from 0 to 50. Just for fun, double-click on the 25 to 30 meter color contour and change it to a light gray, and then click the Exit button. Click the Continue button. The new map shows the 25 to 30 meter thickness as light gray. We encourage you to experiment with other options for creating custom-colored tables. When you are finished, close the Stratigraphy 2D Isopach map window. You don't need to save the map.